Hey everyone, it's Mr. Cure. This video we're going to be looking at how we can figure out how many entities there are in a certain mass of something. First thing you need to do is you have to figure out what kind of entity you're dealing with. So let's look at some of these. So what I have here, I've got carbon dioxide. So carbon dioxide, remember, is a molecular compound that's made up of molecules. So you can be counting molecules, and then you can be counting atoms. If I had magnesium chloride, that'll be a little bit different because I have a formula unit. And from the formula unit, I can figure out the number of anions or even the number of cations. So here I'd have one magnesium cation and two anions. Similarly over here, I'm going to have my sodium bicarbonate. I'm going to have a formula unit. And you're going to have your anion and cation. Aluminum is pure. So it's just an element, so you're going to be looking at only atoms. And finally over here, just look at this for a bit, you have sucrose. Sucrose is a molecule. And from the molecule, you're going to be able to figure out the number of atoms, how many carbon, hydrogen, or oxygen atoms there are. So for example, here I've got 11 oxygen atoms in this particular molecule. And here I've got a hydrate. Hydrate's a little trickier because you've got an ionic component with ions. We also have a molecular component. We've got 5 water molecules associated with this. You have to be careful with that. So it's a little bit different. And because it's a hydrate and it has ionic and molecular components, I can't call this a molecule or formula unit. I call this an entity. So when you're counting hydrates, use the word entity. Just be very specific there. Okay, now how about molar mass? How do we figure out the molar mass? Well, it's also important for us today. To determine the molar mass, you simply look at your periodic table. And when you look at the periodic table, the atomic mass represents the mass of 1 mole of something. So for example, if I've got 1 mole of sodium, it has a mass of 22.99 grams. Similarly, chlorine has a mass of 35.45 grams per mole. However, what if it had something like this, sodium chloride? Well, what you do, you're going to have 1 ion of sodium, 1 of chlorine. So simply add these together to get your overall molar mass. So 1 mole of sodium chloride has a mass of 58.44 grams per mole. Exactly what we talked about before. And here's some other examples for glucose and copper sulfate. Again, it's exactly the same thing. All I did here, let's look at the copper sulfate for a moment, is you look at the number of each atom that's present in the compound. So we got 1 copper, 1 sulfur, 4 oxygens, and then from that you determine the overall mass from the atomic mass, but you convert it into grams per mole. So 1 mole of copper sulfate has a mass of 159.61 grams. All right, let's look at an example here. So let's say I've got a container, and the container has some aluminum chloride in it. The empty beaker is 116.5, the full one is 135.8. So I want to know how many anions are present in the sample. How do we do that? Well, what I'm going to do is I have to figure out the mass of the aluminum chloride. And once I know the mass of the aluminum chloride, I can figure out the number of moles from the molar mass, figure out how many formula units there are, and finally how many anions there are in the sample. So let's look at how we do this. So the first step, we figure out how many grams of aluminum chloride I have. So you subtract, you end up with 19.3 grams. I think that's a typo over here. So just 19.3 grams. And then basically from that, what I'm going to do is from the molar mass, figure out the number of moles and all the way down to the end, like we discussed just a bit before. So what's going to happen? I'll determine the molar mass of the aluminum chloride. So if I have 1 mole of aluminum chloride, it has a mass of 133.33 grams. Well, I only have 19.3 grams. What does that mean? I don't have a full mole. In fact, I only have about 0.14475 of a mole. It's about 14 or 15% of a mole. So from this, I can now say, hey, how many formula units do I have? So what you use is Avogadro's number. So if I only have 15% of a mole, I've got 15% of Avogadro's number, which is 8.7142 times 10 to the 22 formula units. Remember, these are ions over here. And for every 1 aluminum chloride formula unit over here, I've got 3 of these chlorine anions. So I simply take the number of formula units times by 3. So I have 2.614 times 10 to the 23 chlorine anions. Now, with significant digits, I'm going to go way back up to the top here. I got 3 significant digits here from my mass. That's how many significant digits I have in my final answer. So I've got 2.61 times 10 to the 23 chlorine anions in my beaker. How cool is that? We can figure out how many anions are floating around in here. Okay, now, what if I have something different? What if I have a molecular compound? Well, it's exactly the same. What you do is you determine the number of moles. From the moles, you're going to determine the number of molecules. And then from the molecules, you're going to determine the number of atoms. So for example, here you're going to be looking at carbon atoms. So here's my little flow chart. So the idea here is you have your molar mass, figure out the moles, Avogadro's number to figure out the number of molecules. I should have molecules here. And then from that, I'm going to figure out how many carbon atoms there are present in the sample. All right, so let's look at how we do that. So first of all, I'm going to determine how many carbon atoms are present in the sample. So, or the mass, sorry, in the sample. So I'm going to figure out how many grams we have in the particular sample. So empty beaker was 116.5. My sample is inside the beaker with the beaker together is going to be 178.3 grams. Okay, so first step is to determine the amount of glucose in the beaker. So we simply subtract the mass of the glucose and beaker from the beaker that's empty. So you end up with 61.8 grams. And now what we can do is the following. So what I'm going to do is from the mass, I'm going to determine the molar mass and the number of moles. And then once I have the number of moles, I'll figure out how many molecules we have and then how many carbon atoms. So let's look at this. So for the molar mass, I'm going to have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygens. So for a total of 180.18 grams in 1 moles of this glucose. Now, I only have 61.8 grams. That's not a full mole. So I multiply through, and what's going to happen is my units are going to be canceling here. So the grams are going to cancel. And then what's going to happen, there we go. I'm going to end up with 0.34299 moles of glucose. Well, if I know the number of moles, I can figure out how many molecules I have from Avogadro's number. So I've got about 34% of a mole, which means I've got 2.0648 times 10 to the 23 molecules of glucose. Then the next step and the final step is once I have the number of molecules, I know there's 6 carbon atoms in each molecule, which gives me 1.2389 times 10 to the 24th carbon atoms. Now with significant digits, I have 3 here. So my final answer is going to contain 1.24 times 10 to the 24th carbon atoms in that little sample. It's hard to believe, but that's how it works. So the rest of the examples you're going to be going through are going to be very, very similar. You're going to be primarily dealing with molecular and ionic compounds. Every now and then you might have a hydrate. But again, you'll be able to figure it out. So the basic flow chart is here. You always start with the mass, figure out the moles, figure out the number of entities. Could be molecule, could be formula units, and then find the atoms or ions depending on what you have. And that's it.